Alright, here we got the base of a solid is the shaded region in the xy plane enclosed by the x-axis, y-axis, and the graph of y equals 1 minus sine for each x. The cross-section of s perpendicular to the x-axis to the point x0 is an isosceles right triangle whose hypotenuse lies in the xy plane. What the hell did we just read? Well, if we want to start understanding what the hell is going on, we should probably try to think about what the graph of 1 minus sine x looks like. Now, I'll tell you that sine x looks like that. Negative sine x looks like that. 1 minus sine x looks like that. Now, what the hell just happened here? Well, sine normally starts in the middle. Now, if you put a negative in the front, that doesn't change anything. If you put a 1 in the front of that, that's going to move everything up by 1. So that means you're going to be looking at that, and now the x and y axis. So that means the region that you and I are interested in is boom, right there. Okay, so for each x, the cross section of s perpendicular to the x-axis. Okay, so let's just draw in something that maybe looks like this. And that is actually supposed to be the hypotenuse, which lies in the xy plane. But the cross section of S perpendicular to the x-axis is an isosceles right triangle. Okay, so let's have a right triangle be jutting out of this. Now it's supposed to be isosceles. And then it's also got to have some sort of width to it. And we could say that the width here would be like a dx. So I could draw what the full-on triangle looks like if I were to do something that looks like this. Crappy drawing time. There you go. And that goes there. That goes there, and now it kind of looks a little bit more 3D, where we would say that the distance between here and here, that's just going to be dx. So ultimately we know that we're going to have to do the volume of S is going to be the integral of the area, and then there's going to be a dx. Now in part A, they just want you to find the area, and they want it as a function of x, which is a good idea because we have a dx, so everything has to be in terms of x. But now, why am I writing this? Well, this is the formula that you use whenever you know the area of a cross section and you're trying to find the volume, which is what we're trying to do in part B. So now let's talk about what the formula for the area should be. Well, it's 1/2 base times height. But what would the base and the height be? Well, if this is the hypotenuse, then that hypotenuse is actually the same thing as the y coordinate. So I could say that the hypotenuse has a length of y. And when you're dealing with an isosceles right triangle, namely where this side is equal to that side, then you can always divide by √2 to figure out the leg. Because if you were going the other way around, you would actually multiply by √2. So this leg would be y divided by √2. Now, of course, the other leg would also be y divided by √2. So that would be your base and your height. So it's actually going to be, instead of base times height, I could just write y divided by √2 squared. But that's not cool because that is not a function of x. So we got to remember what the y coordinate is here, and it's actually 1 minus sine. So instead of putting y, I'm going to replace that with 1 minus sine. So it's that over √2 n squared, and don't forget your 1/2. So the answer to A would be this. This is the formula for the area of the triangle. However, that's really just kind of a stepping stone to us trying to find the answer to part B. And the answer to part B is where you're going to have to take the integral of that, slap a dx at the end of it, and also recognize what the limits are. Now, in this case, it's going to be starting at x equals 0, and then it's going to be ending at what? When does the y equal 0? Well, when, sorry, what x would make the y 0? That's what I should have said. And you plug in the 0 for y, and then you find out it's when sine x equals 1. Well, when does sine x equals 1? Oh, that's right, pi over 2. So that would be the starting point of this. Now, we need to simplify this a little bit. I'm going to bring the 1/2 outside, and then we got 1 minus sine squared up top. So that would be the same thing as 1 minus 2 sine plus sine squared. And we're also squaring the bottom, so that would actually get you a 2. And then let's see, what do we want to do? Pull out another 1/2. So instead of putting this over 2 right here, we can pull that out as a 1/2. Since there's already a 1/2 there, that's ultimately going to turn into a 1/4. But you would have 1 minus 2 sine x plus sine squared. Now, sine squared is not your friend when you're trying to take an integral. But we do have a cozy little formula for sine squared. We also have one for cosine squared in case you ever encounter that. But sine squared can be swapped out for this, and notice how there's a very similar formula for cosine. When you're dealing with cosine squared, you deal with a positive in front of the cosine 2 theta. When you're dealing with sine squared, well, negative. Okay, so what we want to do is swap out that sine squared for this guy. Now, in our case, it's not really a theta, it's an x, so I'll just change that. Other than that, it's the exact same as what you just saw right there. And that's going to make it easier to take the integral. It's like the way to do it, actually. And now we're actually going to have to take the integral. So the integral of 1, that is x. Am I covering up any of this? I hope I'm not. Anyway, so this is x, and then minus 2 negative cosine, so that would be plus 2 cosine. And then we're also going to have a half times integral of 1 is x. Integral of cosine 2x is sine 2x over 2. Close this parenthesis, close that parenthesis. And we're doing that all from 0 to pi over 2. Now this is the boring part where you have to plug everything in. But let's see, it's going to be, what's the best way to do this? I guess we'll simplify first. We'll do 1/4 x plus 2 cosine x over 4 plus 1/2 x times 1/4, which is 1/8 x. And then similar story for the other one. It's going to be minus 1/8 sine 2x. And I kind of feel like bailing at this point because it's just complicated plugging in, and that's exactly what we're going to do. So guess you guys knew how to finish plugging in, and we're going to stop there. But yeah, you would want to keep going. But that's not what this video is about. This video is about setting up and making sure you understood how to plug into the volume equals the integral of the area of the cross section formula, and recognizing that this was the length of your side, this was the length of your leg. So we had a hypotenuse, but then we had to divide by root 2 to get the length of the leg, and this leg is the same. So when you want the area of that triangle, it's 1/2 times that squared. And don't forget about your dx, and then don't forget about using this formula. All right, hope that was helpful.